My name is Hannah Horn and the title of my project is Skeleton VR for Oculus Quest. Veterinary students face a great challenge when it comes to learning anatomy. Not only is it a vast area of knowledge, but the current curriculum provides less time to learning it and there's a lack of interactive resources available. The aims of this study are to gain an understanding of the impact that existing resources available to veterinary students have and identify the gaps in their education, and to design and develop an educational VR application that will aid the learning of the canine skeleton for veterinary students. Technological advances with interactive 3D anatomical models have become established in medical training, yet these advances haven't been carried over to veterinary education. The limited resources are the main reason for this project, as it aims to bring some of these technological advances into veterinary education, which will offer opportunities for enhanced visualization and interactions with digital models. It will also allow for remote teaching and learning, and to date there is no immersive learning application for veterinary students for the canine skeleton, which this project aims to provide. There were three main steps used in the design of the application: the initial concept, the workflow, and the storyboard, and the three main steps for the development of the application: segmentation, retopology, and the application creation. Workflow diagrams were created to demonstrate the methodologies used. The first methodology was the segmentation of the dataset, which was carried out using 3D Slicer. The painting tool with a threshold set on it was used to extract the contours of the required bones and was then viewed in the segment editor as a 3D model. If the model looked acceptable, then it would be exported as an STL file. If the model wasn't suitable, then it would go back to the painting stage of the segmentation to manually touch up the models. The exported models would be brought into 3ds Max to be retopologized. This stage is required as the models produced by 3D Slicer have a high number of polygons and even some holes in the meshes. A new object would be created and set to be drawn on the surface of the model. Using the strip function, a line of polygons are created. Then, using the extend tool, polygons were created and manipulated until the model was finished. If the model was suitable, then auto-smoothing groups were added to the model before exporting it. If the model wasn't suitable, then the new object would be deleted and the strip process would start again. The last methodology was the application creation. It required assets and packages from the Unity Asset Store to be installed into the project and for the application to be set to an Android build. The models created in the previous methodologies were imported. The UI and functionality of the application was also worked on. This would then be test built and installed into the Oculus Quest for debugging. Once the application was functional and met the requirements of the aims, then the final build was made. The result of those methodologies was an interactive and educational application. The user can navigate the environment, listen to the audio recordings on the tables, and they can use the play, pause, and stop functions so that the audio can be played as the user desires. There are also diagrams for each of the models. These are on clipboards on a different table. Using the clipboard, the diagram on it can be used to identify the different processes on each of the models. They can then test their knowledge learned using the quiz, which provides instant feedback using the confirm button. Due to the timescale assigned to this project, a full-scale quiz was not made, but instead a sample quiz that can be easily altered to have more questions was designed. The application also didn't go through any evaluative processes from outside sources, which means that one of the future considerations for this application is to have the usability of it tested. Another future consideration is to expand the application to have a mini-game of sorting the different bones into categories, and also to include the entire canine skeleton. These methodologies can also be applied to other areas in veterinary anatomy, including not just the organs of the canine, but other species of animals as well. Thank you for listening. For any questions, feel free to email me on one of the email addresses shown below.